Hey everyone, I am Priyanshi Agrawal and welcome back to my YouTube channel. Now we will be solving today's Leetcode daily challenge, which is Tuple with Same Product. And past couple of videos I am receiving comment that I should increase my code editor size while coding. So I have increased it in my one video, but again forget to increase it in another videos. Sorry for that. I will try to keep it in mind from next time onwards. And let's see what is this question and how we can solve it. So in this question, you are given an array nums of distinct positive integers and you need to return the number of tuples such that a into v equals to c into d, where a, b, c and d are elements of nums and all are different. Okay, so this is looking kind of similar to a problem 4 sum, right? In that also we need to return a tuple of 4 different integers, but instead of the multiplication we need to return the pair of the sum, right? So this is a kind of similar to that question, but let's see how we can solve this question. So as you can see in this example, 2, 3, 4 and 6, what pairs we can form? 6, 2, 4, 3, right? 6 into 2 equals to 4 into 3, 12 equals to 12, right? So as you can see, we can form only one pair. Instead, its answer is 8. Okay, so let's see why. So even if we can form only single pair, right? A into B equals to C into D. But we can arrange the digits in this pair in 8 ways. How? See. First we have pair A into B, C into D, right? Then A into B can be arranged, right? Okay, and then if we arrange A into B, then on the other hand D into C into D can also be swapped. And if we don't swap A into B, then C into D can be swapped, right? Similarly, if we swap the positions of A into B and C into D, C and D are on the left hand side and A into B are on the right hand side. Then we again swap C and D and then leave A and B as it is, and then swap A and B as well, and then leave C and D as it is, and then swap A and B. So in this way, a single tuple can be arranged in 8 ways. So that's why for a single tuple we are returning 8. Similarly, if we have 2 tuples, then we can arrange them in 16 ways, right? Okay, so the very basic brute force approach way we can simply implement 4 for loops, that is I, j, k and l, right? And then get the product of I and j and k and l and compare whether they are equal or not. If they are equal, then we will simply increment our count by 8, right? Okay, one thing to keep in mind here is that you can see it is 2, 3, 4 and 6, and if you keep I, j, k and l, and if you try to equate the product of I into j equals to k into l, then it will never work because it is sorted in ascending order. Okay, but we can be given with an array that can be sorted or not sorted. It is not given in the question, but for now this array is given in the sorted order. Okay, so if a array is given in a sorted order and you will try to equate this I into j equals to k into l, then it will never become equal. Why? Because this will always be smaller than this, right? Because it is sorted, so 6 will always be smaller than 4 into 6, right? So in this way you can never. So let's take the case of sorted only. If it is not given in sorted order, then we will sort it. So what we can do is we can take the indexes in this way: I, j, k and l, right? Now if you try to equate the product of I into j with k into l, then it will work because I is the smallest, j is largest and k and l are among between them. As you can see, 6 into 2 equals to 3 into 4, right? Okay, so let's see its code first. First we have sorted it because we have not been given in the question that always we have been given with a sorted or not. So we will sort it, and then we'll run an I loop, and then we'll run a j loop from n minus 1, and then we will calculate its product, and then we will start a k loop from I plus 1 with less than j, an L loop with k plus 1 with less than j, and we see if their product are equals to the product, then we will simply increment our count by 8. So its time complexity will be big of n की power 4 and its space complexity will be big of 1, right? Okay, so as its time complexity is n की power 4 and what is n? 10 की power 3. It means 10 की power 3 की power 4, that is 10 की power 12. So obviously that is not going to work. Okay, so let's see, can we further optimize it? Okay, so how remember how we optimize this thing in the four sum problem. Like we also solve the four sum problem with the similar brute force approach with the four for loops. So how can we optimize? Can we reduce this the last nested for loop? Okay, let's see if we can reduce this. Let's take the example of 2 3 4 and 6. 2 3 4 and 6. Okay, so what we are thinking is that our I is this, j is this. Okay, perfect. We have 12 in our product right now, but instead of calculating the product of numbers between them, can we just do a lookup to find whether it is whether their product are equal or not? Okay, so let's start iterating on the elements between I and j. Okay, so let's go to 3. So how we will get it the product? Okay, so remember what we do in foursome, similarly we will do in this also. So the product is 12 and right now we are at 3, so let's divide 12 by 3, so it will become 4. So we will create an unordered set for storing the numbers which we have already visited between I and j. So right now when we are at 3, there is nothing in our set, so we will simply divide 12 by 3, which is 4. So right now our set is empty, so we will store the 3 in our set because we have visited 3. And now again we are at 4 now. Now again let's divide 12 by 4. 4 by 12 by 4 is 3. Now again we will do a lookup in our set. Does 3 exist in our set? Oh yeah, 3 exists in our set. So right now we are at 4, right? And 3 exists in our set. So it means their product is 12, because why? We are dividing 12 by 4, that is 3, and we have already visited 3 in our past. So in this way we are not needing to calculate the product again and again, and we can do a lookup in our set and find whether the product is equal or not, right? Because we have divided 12 by this number and the quotient which has already occurred in the past. It means if we multiply 4 and 3, then it will give us the existing product, right? Okay, so let's see its code as well. So we have not changed this outer nested for loops and also calculating its product, and then we have created a set occurred, the number which has already occurred, and then starting a for loop from I plus 1 till less than j, and if the remainder should be 0 and the quotient already exists in the, and the quotient which is the like 3 in the above example already occurred, it means we have got our pair. 3 into 4 is equals to 6 into 2. So we will increment the count by 2 and we will insert that number in our set for further pairs, right? So what will be its time complexity? Its time complexity will be big O of n की power 3 and its space complexity will be big O of n, right? Because in the occurred we are storing the numbers of the array, so it can store up to n numbers, so that's why its space complexity will be big O of n. So the time complexity is 10 की power 3, right? As n is 10 की power 3. So 10 की power 9 is also not going to work. It will also give TLE. Okay. So now we will also need to optimize this nested loop. It means we can just calculate the product of two numbers only, right? Okay, so let's see if we can solve this problem by just calculating the product of two numbers. Let's take this example now. 1, 2, 4, 5 and 10. Okay, 1, 2, 4, 5 and 10. Now we can't do anything, we just can calculate the product of all the numbers. Okay, so if we are calculating the product of all the numbers, obviously we will be needing either a hash set or hash map for storing the count. So let's take a hash map so that we can store the count of the products. Okay, so first let's calculate the product of this. This is 2. Product of 2, we how many times we got product as 2, right? 10 now 1. Okay, now let's calculate the product of 4 and 1. So this is 4, and again 5 and 1, this is 5, and again 10 and 1, this is 10, and now again 4 into 2 8, this is also 1, 5 into 2 10. Oh, 10 has occurred in the past, so we will update it. 10 into 2 20, it's also 1. 5 into 4 20. Okay, so 20 has already occurred, so we will increment its count. 10 into 4 40. Okay, 5 into 10 50. Okay, so we can only run a nested loop, so that, and what we can do maximum, what we can do in a nested loop, we can just calculate the product of the numbers. Okay, so can you see, like, if we are calculating the product, let's say we have calculated the product 10 and it occurred 2 times, so there must exist 2 pairs which have provided the product as 2. Why? Because if A into B is giving the product as 10, then in the second time also there is a different pair. Why? Because if there is B only, so there should be A, and we are not repeating the pairs, right? So that's why 2 distinct pairs have given this product, right? So in here 20, for 20 as well, there must be 2 distinct pairs which have given 20 as product. Okay, so if we have 2 distinct pairs, it means 8 ways, right? As we have seen above, like if we have 2 pairs, then we can arrange them in 8 ways. Okay, and for 20 as well, if there are 8 ways, okay, then 8 plus 8, that is 16. Okay, so let's see what was our answer. Oh, our answer was also 16. Cool. So I think we get something from this while storing the count of product of all the numbers. Okay, so let's see how we can code it. Let me give you like further more intuition. Let's say instead of 10 there was 3. So sorry, instead of the count of 10 as 2, there was 3. So what will happen? Let's see once. So it means there must exist 3 pairs, A, B, C, D, E and F, right? So how many ways in which, how many tuples will exist? So while doing the lookup for C into D, 10 is also already storing count as 1 because of A into B, right? So it can form 8 tuples, right? So we will check if it already exists. So we will simply multiply the count of this by 8, right? And then we will increment the count of 10 because we have got one more tuple, right? And then we will again get the count as 10. So we will see, oh, 10 has already occurred, and there was 2 pairs which gave 10 as product, right? So what we will do, we will again then multiply 2 by 8. Why? Because A into B equals to E into F can form 8 pairs, and C into D equals to E and into F can form 8 pairs, right? So in this way we will get our answer. So what we have done here is that we are simply iterating in the array, calculating the product, and if that product already exists in the map, then we will simply take the count of that product from the map and multiply it by 8 and add to our answer, because there are 8 ways in which the numbers in that pair can be arranged. Okay, so let's see its code now. So what we have done here is that we have created a product count unordered map, and we have started iterating in our for loop and take count and take the product of those two numbers. And if that product exists in our map, then what we will do, we will simply increment our count by 8 into product count and again update our map with that product. So what will be its time complexity? Its time complexity will be big O of n square, and its space complexity will also be big O of n square, because we are storing all the products in our map and there can be up to maximum of n square products. So that's why its space complexity will also be n square. So yeah, this was all for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.